privilege to be here. I want to say how much I admire all of you in the room, and how much I look forward to learning from you today. I want to thank you, send a big shout out to MCAT for making today's video production possible. Thank you very much for your time and your resources. Dr. David Mattson, short, brief intro here, certainly deserves much more than what I'm about to say. 40-year career specializing in research in cougars and grizzly bears, including work in Yellowstone. His biggest focus currently is connecting science with advocacy, resulting in good policy, particularly for the bears. Dr. David Mattson.
Well, I am definitely humble here standing before you guys. You are the cream of the crop. I mean, it'd be nice to see a fewer blue heads out there in the audience, but anyway, that's a whole nother topic. So yes, I really appreciate your taking time out of what I'm sure are busy schedules. I'm excited about giving this talk. I don't mean to sound like a TV show host, but this is something that's been in the works for probably 4 years now, an evolving talk. And the genesis for it was primarily me wanting to make sense out of what has been going on with grizzly bears and grizzly bear habitat in this part of the world, what is going on now, what's likely to go on in the future. So the fundamental motivation for me has been curiosity and coming up with a narrative that's sufficient to explain stuff to myself, and I hope that will be the case for you. But also, part of the motivation for me was listening to a narrative that has been recited over and over and over again by government spokespeople, which I'm sure you're well acquainted with, a very straightforward narrative. We've got more bears in more places, therefore we need to remove Endangered Species Act protections and almost certainly then institute a trophy hunt. Now, being an ecologist, when I hear a simple-minded, well, I shouldn't be disparaging, a simplistic story like that about what I know is a complex system, red flags go up all over. That also then was the impetus to get into the guts of what we know about this ecosystem and the bears in it. So what I'm offering is a perspective. It's not God's truth, obviously, but it's a perspective. There are a lot of people that know more about grizzly bears in this part of the world than I do, including in this room. But what I would like to think I can offer you is a coherent, alternative, perhaps compelling narrative that explains what's going on, that is counter to this fairly simple-minded story we're hearing over and over again from the government. So all the logos there, hopefully acknowledging everybody that has made a contribution to making this event happen. I'd like to do a special shout out to Louisa, sorry. Anyway, as is my habit, I'm going to try to cover way too much ground, way too quickly, but I think that's what's required if we're going to have a sufficient explanation for what is happening with bears and their ecosystem. You can't do it in 15 minutes. So, hopefully getting this to work. I do have to confess to having gotten this picture and then inserted the bear. So this is an image that, a hopeful image, an aspiration to some sort of future that, okay, I think we're moving here. Okay, so as I was saying, covering a lot of ground way too quickly, and in service of you trying to keep track of where I'm headed, a bit of a roadmap is probably appropriate. I'm going to start with how and when grizzly bears got to this part of the world, what subsequently happened to them, which was largely extirpations at the hands of Europeans. Then look at diet. And I would argue that that is a fundamental foundation if you're going to understand anything about what happens with grizzly bears. You need to know what they're eating and where, which maps quite closely, as it turns out, onto the nature of human grizzly bear conflicts and sort of the geographic variation in the nature of those conflicts, what I call conflict regimes. And then with those foundations in place, I think one can then usefully engage with these more arcane notions of demography, less arcane distribution, which is sort of a derivative of demography. With all of that in place, then look a little bit at the future, which is certainly going to be different than what we have now. And then finally, in light of all that, ask the question, how many bears and how many places are enough? Which then leads to a concluding bit about what I would call a metavision, which is a more generous vision for recovery of grizzly bears in this part of the world. So arrivals and departures. This is actually a bear on the tundra in Manitoba, taken by a friend of mine. What you see in green here is roughly where we had grizzly bears about the time that Europeans were arriving on the continent. Two different shades of green. The lighter green represents a unique, distinctive genetic lineage called clade 4. These bears were at mid-latitudes on this continent about 30,000 years ago. They were amongst the very first wave of migrant bears onto this continent from Eurasia via Beringia. To the north, we have clade 3 grizzly bears, which are more recent arrivals during the height of the Pleistocene. So as the ice sheets melted, the Laurentide and the Cordilleran, and an ice-free corridor opened up, clade 3 grizzly bears spread south, clade 4 grizzly bears spread north. Now importantly, clade 3 grizzly bears never got any further south than central Alberta, southeastern BC. The upshot is that all of the grizzly bears that we once had at mid-latitudes on this continent were clade 4 bears of this most ancient lineage, this first wave of migrants. And they have gone extinct everywhere else on Earth, except for a small isolate on the Japanese island of Hokkaido. So we have special bears here by virtue of this evolutionary history.
Dave, what's the story with northern Quebec and all that?
And what's
the green spot in northern Quebec?
the Laurentide population? We don't really know. I mean, because we had these bears spreading out at the end of the last ice age, tracking retreat of the ice sheets north. That's where the ice sheets hung on latest. It's unlikely that these clade 3 bears could have gotten over because the ice would have been in the way, but I think clade 4 bears were tracking it north. And what we do know is that there were bears in that part of Labrador, and that they're now extinct. So an interesting little bit of history. So everything you see here in green, clade 4 bears, and then what was to become the western contiguous US about 1800, which is a pregnant time because that's when grizzly bears were first encountering significant numbers of Europeans. 50 years later, grizzly bears were pretty much extirpated from the central and southern plains, everything you see in yellow. 60 years after that, they were reduced to these scattered small populations denoted by green here. Some of these populations, no more than just a few bears. So we'd lost already 90% of what we had. 60 years after that, we were left largely with what we have now, bears mostly in the northern continental divide, greater Yellowstone, a few bears in the North Cascades, and a couple in the San Juan Mountains. Now, why did we lose so many bears so quickly? It's not too mysterious. Europeans armed with large caliber firearms, bad attitudes informed by narratives like manifest destiny, which at least in their minds, gave our European ancestors permission to perpetrate genocides against bison, wolves, grizzly bears, native peoples. So this is what we were left with. And from this point on, the focus is going to be on what the Fish and Wildlife Service calls the Northern Continental Divide ecosystem, what I've come to think of as the heart of the Grizzly Bear Nation. And I'll get into the reasons why I think that closer to the end of the talk. Meanwhile, what did bears eat in this part of the world, in the Northern Rockies, say about the time of European contact? First of all, noting that everything in green here represents the presence of a berry-producing shrub in toto. The darker the green, the greater the abundance of berry-producing shrubs, the greater the diversity. So to the west, we had what I would call a salmon berry dietary economy, of course, anadromous salmon. As we move into the mountains, pick up a little more diversity, foods like white bark pine seeds, army cutworm moths, different suite of berries yet. You move further east out on the plains, and we're into a bison-centric dietary economy. Other foods, but certainly bison, were foremost as a source of energy and nutrients for bears. So fast forward a couple of centuries, some of the foods have persisted, but we've lost others. Functionally, insofar as bears are concerned, anadromous salmon are gone. In the mountains, some gains, but mostly losses that I'll get into a little bit later. And of course, as we move out into the plains, what we have now is a cattle-centered dietary economy, which I will circle back to a little bit later when I talk about conflicts. Thanks to the work of Rick Mace, we have this map that basically shows a gradient of consumption of meat in the Northern Continental Divide ecosystem. The darker the red, the greater the amounts of meat in the diet. So as you move further east and south, more and more meat. Furthest to the northwest, bears subsisting primarily on vegetation of one sort or another, a berry-centered economy versus a meat-centered economy. Rendering in this into some somewhat more literal terms, these pie diagrams represent the results of analyses of scats in 3 different study areas, 2 on the west side, 1 on the east front. Everything in blue represents the contribution of berries. So a lot more berries being eaten by bears on the west side. Looking at burgundy, it would suggest, based on scats, comparable amounts of ingested meat. But what's really important here is the sources of meat are quite different. For example, in North Fork of the Flathead, elk. Around Glacier National Park, white-tailed deer. You go east out on the plains, mostly livestock. And this was back in the mid-1980s, thanks to work by Keith Awney. Second to livestock, deer again, mule deer. And on the east front, at least historically, in the mid-1980s, a significant amount of white bark pine seeds, some insects, more insects there than on the west side. An often overlooked food, army cutworm moths. Now, army cutworm moths aggregate in the alpine and alpine talus during the summer. While they're there, they subsist on the nectar of alpine tundra flowers. Everything in green here then is an alpine environment mapped for the entire Northern Rockies. Here's our 2 largest recovery areas. But more to the point, everything encompassed by a greenish blob here is where bears have been documented feeding on concentrations of army cutworm moths in the alpine. Now, I suspect that actually army cutworm moths are a more important source of energy and nutrients than we often credit, but we don't know. There hasn't been much work done on army cutworm moths, certainly in the Northern Continental Divide, since Kate Kendall was involved in research going on in Park. So, to simplify things, we have basically a west side dietary economy and an east front dietary economy. So with that in mind, it's worth then contemplating human grizzly bear conflict regimes, because those regimes map quite closely onto geographic differences in diet, which are a reflection of underlying environments. So I think actually this is good advice. I mean, it's basically emblematic of where we could go. Now, there's a reason for focusing on conflict regimes, conflicts between bears and humans, if for no other reason than 90% of all the bears dying die because a human kills it. And this is based on the fates of radiomarked bears, so it's a relatively less biased way of assessing the importance of human-caused mortality. So if we want to conserve bears, we got to deal with conflicts that lead to deaths. So, as per diet, west side conflict regimes, east front conflict regimes. As to why we have some differences in the genesis or causes of conflict, again, a lot to do with environment, the manifestations of humans in those environments, and in particular, when we look at the east front versus the west side, we've got a lot more cattle on the east front, roughly 3 times the densities on the east front. And that matters. The height of those different colored bars represents the proportional causes of mortality for grizzly bears, here primarily human causes. The burgundy represents the proportion of bears on the east front dying because of conflicts over livestock. The red bar being killed by big game hunters because of surprise encounters, because bears are seeking out gut piles, everything that brings hunters and bears together. So a lot more bears dying on the east side because of meat-related conflicts or encounters with people. So the focus is on meat. On the east side, it's worth differentiating 2 different regimes within this larger regime, a backcountry regime where most conflicts organize again around big game hunting, and then a regime centered on agricultural landscapes. And I'm not going to talk much more about the backcountry because most of the conflicts anymore are happening in these agricultural landscapes. So there's a particular geospatial configuration to bears in those landscapes, and because of that, conflicts. Emblematic of that, we're looking at Shoto to the west toward the mountains. Each one of those dots is a radiotelemetry location for a grizzly bear. You can see they're non-randomly distributed in those landscapes. As it turns out, the grizzly bears are following riparian areas for good reason. That's where not only the natural foods are concentrated, but also the anthropogenic foods. So, if, as we did in this white masked area, we comprehensively map all the conflicts that have occurred and then create an isopleth map on top of that representing densities of conflicts, so the darker the red, the more conflicts per unit area. You can see that those also follow riparian areas. Now, realizing that that is a derivative of the human attractants along riparian areas. Most beehives, most boneyards, most calving areas, most lambing areas in that part of the world are along riparian areas. So this is no mystery, no surprise. Now we scale up, step back here going just north of the Montana border into southwestern Alberta, looking at the results of some research that were done by Mark Boyce and his graduate students. Everything that's shades of red and orange are what they call ecological traps. In other words, productive habitat that draws bears into risky environment where odds of them dying are elevated. And that's perfectly good food out here. It's just that as a consequence of seeking that food out, the bears more often end up dying. And so in contrast to secure productive habitat further into the mountains. Now, an important point to make here is that it is not ineluctable, not inescapable that we have ecological traps out here. It has to do with how we humans respond to conflicts as to whether it turns into a trap or some sort of a benefit for the bears. And to highlight that, I'm going to move south to a different part of this larger agricultural landscape into the Blackfoot River drainage, focusing on the Blackfoot Challenge, which is a community-based grassroots organization convened, constituted to deal with natural resources challenges. As along the east front in this landscape, here you're looking at the red dots being where bears were documented. between 1998 and 2004, which is when bears were first arriving in this landscape. Again, non-random. And then when you map riparian areas and conflicts, the same sort of pattern. So much the same was going on in terms of that human-bear interaction here, or at least in the terms of the geospatial configuration, compared to the East Front. But how people responded to that was radically different in the Blackfoot. They aggressively deployed all sorts of measures to mitigate and prevent conflicts, including lots of electric fencing around beehives, calving areas, retrieving carcasses from boneyards, putting them into secure facilities where they can be composted, and other things. With results, pretty dramatic results. So here's 2003. Each one of these gray dots represents numbers of conflicts during any given year. And as bears were colonizing, conflicts were going off the charts. These mitigative measures were implemented. Conflicts dropped by over 90%. So again, these landscapes do not need to be lethal to bears. We have choices and options. Another important thing about the Blackfoot Challenge, somewhat fortuitously, is its geographic location relative to all of the dispersal routes that have been mapped by various researchers in various shades of burgundy and orange. See how it sits at this nexus for dispersal of bears outward to the south and southwest. And so I don't think it's by coincidence when you plop down on that, all the dispersing grizzly bears that have been documented coming from the NCDE, that you can logically trace them back to that part of the ecosystem. So it matters whether we learn to live with bears or not. And we can. Okay, East Front versus West Side, another big difference has to do with numbers of people. So there's more than 3 times the density of people on the west side compared to the east side, which again matters in terms of the nature of conflicts, why bears die. So here again, the width of those various colored bars represents proportional causes of death for bears. Here, because of removals by managers, most of them because of conflicts organized around attractants at home sites. Defense of life and property, a lot of that in response to similar kinds of conflicts. Collisions with vehicles, not surprising, more people, more traffic, more bears dying because of those collisions. But if we look at the west side, again, it's worth differentiating 2 different regimes within a regime, the front country conflict regime and the roaded industrial conflict regime. Looking first at the front country, not surprisingly, it maps quite closely onto the human footprint. Now, the human footprint just represents all of the modifications we've made in the natural environment. So that the east, most of that is attributable to conversion to croplands, but everywhere else, it's because of numbers of people and numbers of people in residence. So then, because of that, we have a particular configuration of the genesis of conflicts. Again, a lot to do with attractants around home sites, dog food, bird feeders, unsecured garbage, small domesticated animals, notably chickens, and then, of course, collisions along high-speed, high-traffic highways. We know a lot about what to do with attractants around residences. Secure garbage. Get rid of garbage. Bring it in the house. Put it in bear-proof, garbage-resistant containers, or bear-proof, I guess that's redundant. But anyway, it's no mystery about how to deal with these attractants. It's the logistical problems that are the impediment, as well as attitudes. When we look at collisions with cars, it's become more of an issue because we have more and more bears dying because of those collisions. Here up through 2017. So hold on, I'll get to 2018. But even up through 2017, we had a trend towards increasing numbers of bears dying because of collisions, which then was partly the motivation to do what was done along Highway 93 through the Mission Valley installation of a lot of wildlife crossing structures, 39 different locations. Each one of those yellow symbols represents a crossing structure with some demonstrable benefit. In the portions of Highway 93 that were treated, collisions with all wildlife declined by 70 to 80%. Paradoxically, collisions along the entirety of Highway 93 have gone up. And that's because there are so many more cars driving at much higher speeds. And as it turns out, there was no demonstrable benefit for any bear species, black or grizzly bear. This just represents where bears died between 2010 and 2015 along Highway 93. Now, the point here is not that this was futile, but rather if we're going to facilitate passage of wildlife, bears in particular, along highways like this, the treatment needs to be comprehensive. We need crossing structures all along that highway, not just in a few select places. The roaded industrial landscape, which maps quite closely onto lands where we're managing for industrial scale timber production. So everything in Burgundy are lands, public lands now, not private lands, but public lands that are devoted to the production of timber and have a maintained dense road network. Everything in orange is deemed suitable for timber production and candidate for building roads. Now, these landscapes matter just by virtue of that evidence. Each one of those dots represents a dead bear between 2004 and 2014. There is a disproportionate concentration of bears dying, dead bears, in these roaded industrial landscapes. So it matters how we deal with those landscapes, and in particular how we deal with road access. Roads bridge to another cause of death, poaching. In lavender there are the proportion of bears known to have died because of poaching on the west-east side, comparable percentages. But the important point here is that poaching is notoriously under-documented. And to get at a realistic estimate of the proportion of bears dying because of poaching, we need to multiply that by 2 to 3-fold. And the most recent estimate I've seen would suggest that 30% of all the bears that die in the northern continental divide ecosystem are poached. So poaching is really important as an issue, and that issue maps onto how we manage roads, because roads provide poachers with that much greater access to grizzly bear habitat. So with all of that in place, understanding what bears eat, where they eat, how that translates into conflicts, causes of death, I think at that point one can then usefully engage with demography. Now, remember, I would guess talks or what you hear from government spokespeople, they don't even mention all of what comes before this point. We go straight here, which I think is does a real disservice to us understanding what is going on with grizzly bears, especially the grizzly bear-human relations. But getting in demography, what I'm going to do is just start with showing you trends in numbers of bears known to have died in this ecosystem. A gray dot represents each year's mortality, the red squiggly line a moving average for the period 1968 to 1993. Interestingly, during this period of time, we had a sustained decrease per annum in numbers of bears dying, which begs the question, why? Well, bears were listed in 75, I think it is. That probably contributed to the explanation, but paradoxically enough, as you all know, sport hunting continued up until 1991. So it could be, in fact, that this decline in numbers of bears dying might have been just simply a reflection of there being ever fewer bears in the ecosystem to die. We don't know. We have a single point estimate, ballpark estimate, of the number of bears in the ecosystem from this period of time, roughly 680. So moving forward in time then to the period 1993 to 2005, we have a reversal in the trend in the numbers of bears dying, a pretty dramatic per annum increase during those years. We also, for the first time at the end of that period, have a reliable estimate of population size, roughly 765, but it's not clear how we got from roughly 680 to 765. Did we have an increase and a decline, a steady increase, a decline, and then an increase? I think the only way we can really understand these dynamics is by going back again and looking at food and diet. And fortunately, we have a couple of enterprising researchers out there, Bruce McClellan and Wayne Caseworm, that have assiduously documented the sizes of fruit crops for a long time. Each one of the gray dots represents their estimate of crop size for different species. The red squiggly lines, moving averages again. Starting with huckleberry, you can see that we had a long period of large crops, then a dearth, and then recovery. Something similar for buffalo berry. With serviceberry, we had a decline and have yet to see recovery in serviceberry crops. So look at all of the periods of time when we had a dearth of berries. There's a close correspondence. Especially we have a sustained dearth during a particular period of time, roughly 1998 to 2010, which I call the berry famine. And the berry famine mattered to demography. We know that if for no other reason from the research that Bruce McClellan did in the North Fork of the Flathead. Again, he estimated densities of bears each year in the North Fork, represented by brown dots. We can, from that, come up with an estimate of population growth rate, a running average, the gray squares. Here's the berry famine. As soon as the berry famine started, growth rate started to drop. But growth rate did not drop into negative territory for 5 years. Even more notably, we didn't see a pronounced decline in density for around 11 years. Now, the implication of this is that if you're only looking at density, if you're only looking at growth rate, you're going to be looking in a rear view mirror. That you need to be looking at foods, you need to be looking at habitat, if you want to have real-time information about what is happening in a system that may affect demography. Additional evidence. If we partition out what was happening in trends of bears known to die on the west side versus the east side, here again is the berry famine. Notice that numbers of bears dying increased substantially on the west side during the berry famine, with a bit of a lag. Paradoxically, perhaps on the east side, numbers of bears dying was declining. And then remembering that it's on the west side that berries are the most important to bears. So this is what you would expect. We have an upturn in numbers of bears dying on the east front, or beginning around 2009, which I'll come back to a little bit later. So, berry famine. It all makes sense now, at least to me. And what we likely had was an increase in the population and then a decline through the period of that berry famine. In the net, hardly any increase at all, at least when we look at it as a growth rate. Let's move fast forward to 2004, 2009. That matters, for one, because again, we got into the time period when numbers of bears dying per annum was declining at a rapid rate. But it's also the period of time during which Rick Mace was collecting data from radiomarked bears from which to estimate the first ever growth rate for this population, 3.1% per annum. So I'm going to rescale the x-axis so we can focus in on the more recent years, 2002 to 2018. The point here is that Rick happened to sample a period of time that was particularly fortuitous when numbers of bears dying per annum was going down. And what that means to then is that this estimate of growth rate is not extrapolable either into the future period of time or into the past. Now we look at the uncertainty in numbers, his estimate of numbers of bears based upon projecting out 765 to about 2009, anywhere from 500 to 1,350. Project that out to 2014, anywhere from 300 to 2,200 bears in this ecosystem. So with that in mind, along comes Cecily Costello, who comes up with yet another estimate of population growth rate. This time it's 2% per annum. But going back to 2004, including all of Rick's data, a slightly lower estimate of growth rate. Not surprising because numbers of bears dying per annum was yet again climbing. So it's kind of what you would expect. Now, what, though, was attention-getting for me, really striking, is how narrow the bounds of uncertainty were in her estimate of total population size, projecting out from 765 out 10 years forward in time. She's saying, I can tell you how many bears are out there with that degree of confidence. I couldn't believe it. So my reaction was to look at what she had done. Well, she used this, I'm going backwards, sorry. Not uncommon for me. She was using this piece of software called RiskMan, fairly arcane, but often used to simulate population growth. So I took the exact same parameter estimates she used, the exact same estimates of uncertainty on those parameter estimates, introduced them into RiskMan, ran my own projections. This is what I came up with. Same exact estimate, sort of a central tendency of growth rate, but much larger bounds of uncertainty in terms of estimated numbers of bears in this ecosystem. Most liberally, maybe anywhere from 700 to 1,300, more likely between 500 and 1,700, using the exact same software, the exact same parameter estimates. Turns out it comes down to how you treat uncertainty in the context of this software. Now, I'm not going to claim that I did it the best of all possible ways. I think my approach was more plausible. It just points out that you can play all sorts of games with software like this if you want to, depending on how you treat uncertainty. So I came up with estimates of uncertainty that were 220 to 430% greater than what Cecily had come up with. That should be attention-getting. I also created my own population model to be my own simulations, introducing a source sink structure for reasons I'll get into a little later. So what you see in green are the bounds of uncertainty I came up with. Same exact estimate, central tendency of growth rate, but anywhere from 300 to 3,600 bears as of 2014, which is actually closer to what you would have gotten projecting out using Rick's estimate of growth rate. Now, another really important point about all of this is that these estimates of population growth rate are all about looking in the rear view mirror in an egregious sort of way. And to get at that, it's worth looking at the age of the data that were introduced into these models and into these estimates. Now, the width of these gray bars represents the contribution of data from different years to different population estimates. The black vertical bar, is the mean age of the data. So the data that Rick used are now 12 years old. The data that Cecily used, which folded in all of Rick's data, are now 9 to 10 years old, and none of her data are younger than 4 years old. Point of that is we don't have a clue what current population growth rate actually is. And as we go further in time and keep folding in more and more old data, we have estimates of growth rate that are increasingly back-weighted and increasingly irrelevant to what's actually happening now. So what you see there, that green line, is my effort to reconstruct what was most likely happening with this population. So a 3% per annum increase, 2004-2009, connecting the dots in terms of estimated population sizes using Rick's growth rate, Cecily's growth rate. So between 2009 and 2014, that would give us an increase of 1.5% per annum for that period of time specifically. So you take the rate of change or the rate of change, basically the second derivative, and you can project out maybe what was happening from 2014 to 2018. I came up with a negative rate of growth, a decline of 2% per annum. That's just a projection. You could say it's entirely speculation, but I would argue That's a better estimate than anything you've been hearing at workshops sponsored by the state of Montana. The more important point is we don't know. How many bears are out there? The rate at which the population is growing, we don't know. And so there is no legitimate basis for inputting any of that into any sort of projective model by which we would purport to manage grizzly bear mortality in this ecosystem. There is no way we can ensure we will not overharvest a population by a 90% probability. That is nonsense in light of all of this. So I'll leave it at that. Another really important feature about this population and the demography of this population is its source sink structure. A source is nothing more than an area where you have bears being born at a greater rate than they're dying. A sink is where they're dying at a greater rate than they're being born. And to get a sense of why we have a source sink structure, we need to go back in time and revisit a bit of history. Each one of those dots represents a bear that died between 1970 to 79. Almost all of those bears were killed by a trophy hunter. Notice where they're concentrated, in some of what would otherwise be the most remote and secure habitat in the ecosystem, mostly in the Bob Marshall Wilderness. Move ahead in time to 1980, 1997, the pattern persists. This really remarkable concentration of bears in remote areas, the Bob Marshall in particular. A lot of that attributable to trophy hunting. And it's not until we get to 2004, 2014 that we have bears dying in places we would expect them to die because of the ripeness of opportunity for conflicts with humans, intrinsic to those landscapes. But that legacy of bears being killed in the Bob Marshall persists to this day. If you look at the numbers of bears that have been dying relative to estimated densities in different parts of this ecosystem, you can get a sense of the source sink areas. The darker the green, the more vigorous the source. The darker the red, the more pronounced the sink. We have a vigorous source area centered on Glacier National Park. No surprise, also the middle fork of the Flathead. A really pronounced sink as you go west out into the Mission and Flathead valleys. Again, no surprise. So most of the ecosystem is in a sink condition to some extent. Parenthetically, see this green right here? Sort of a low-key source area. Well, first point being that those source areas are subsidizing those sink areas, an outflow of bears. But here's the Blackfoot challenge. It's the exception to this rule, and not by chance. Again, highlighting it is not inevitable that bears will die at a higher rate than they're being born in agricultural landscapes or any of these peripheral landscapes. And this legacy of a sourcing structure shows up when we look at stuff like genetic diversity. Each one of those bears represents a bear that was sampled and analyzed for its diversity, genetic diversity. The larger, darker the dot, the more genetically diverse the animal is. The smaller, the lighter the dot, the less genetically diverse. So we have remarkably impoverished animals, at least genetically, to the south where we had this long persistent sink structure. And it's speculated that that's because we had just a mere handful of wide-ranging males accounting for essentially all of the reproduction in this part of the world. So the source sink structure matters for lots of different reasons, and the rate of flow from source to sink matters as well. And with that in mind then, anything that will impede the flow of bears out of a source area into a sink area matters. And in particular, the Highway 2 transportation corridor. Which takes me back to this graph. Numbers of bears dying because of collisions with automobiles. This doesn't even include trains. And as anybody who's been around here and paying attention knows, this is what we saw this year. Off the charts. So this problem is not going away, it's only getting worse.
David, are there any wildlife crossing structures on this stretch of highway?
Not that I know of.
No.
So the final big topic, distribution. And it's only after having all these pieces in place that I think we can realistically start talking about distribution and what might be driving changes in distribution. So everything in green here is approximately where we had grizzly bears in the 1980s. Fast forward to, well then, partitioning the population between the source and the sink. Fast forward to 2004, we had an expansion in distribution. But notably, population size probably only increased by 10% at the same time that distribution increased by 33%, 3 times more than population size. So simple numbers could not have been driving that magnitude and increase in distribution, which begs the question, what was going on that could have contributed to this rapid expansion of bears up in the northwest off to the east? I would argue the berry famine was going on at this time. So if you have less food where you live, you're probably going to end up in other places, especially if you look up there, that major expansion up to the northwest. But I think there was something else going on of relevant to understanding the expansion of bears out onto the plains during this period of time, having to do with whitebark pine. So everything in shades of burgundy onto yellow represents the totality of the distribution of whitebark pine in western Montana. The shadings represent the number of trees that were dead at that time, 1991, because of a non-native fungal pathogen white pine blister rust. Everything in burgundy, essentially all whitebark pine were dead. But notice along what we would call the east front, there was still lots of whitebark pine producing seeds that would attract bears up into high elevation habitats back into the mountains. And this consumption of whitebark pine seeds is reflected in the diet analysis done by Keith Awney for the mid-1980s. Bears were eating lots of whitebark pine seeds. Go forward in time to 2004, whitebark pine had been extirpated in this ecosystem. So it was gone as a food, not just as a food, but a food that would attract bears back up into the mountains as opposed to otherwise. By that time, 70% of all the mature cone-producing trees were dead. Of the ones left alive, 90% were infected by white pine blister rust, doomed to die, basically. So I would argue it wasn't just the berry famine, but also loss of whitebark pine, contributing to explaining the movement of bears out onto the east front in excess of what you would expect by just simple numbers of bears. Now, looking at 2004, 2009, comparable increases in population and distribution, so there's no real question here, raised by a discrepancy in reflection of the growth rate that Rick estimated for that period of time. How about 2010, 2014? We had only a 6% increase in population size, more than 4 to 5-fold greater increase in distribution. So again, why? Why were bears spreading out so much more quickly than anything we could explain with bear numbers? Which got me to thinking about wildfires. What was going on with wildfires? Well, here's the 1980s distribution again. Here are all the fires that burned post-1980s, everything in red post-1990s. When you put it all together, greater than 25% of the 1980s distribution burned post-1980. But the tempo at which stuff was burning matters. So to get at that, here what I've showed in pink is the cumulative acreage burned post-1980. So here's 1988, and anybody who was around knows that a lot of acreage burned. Mike can testify. But look at this period of time, 1998 to 2007. We had a sustained, rapid accumulation in burned acreage. Now, we know that berry production lags 20 years behind when we have wildfires. So this just simply attracts the accretion of productive berry acreage, which is a good thing for bears, but we shouldn't lose track of these transient, unproductive habitats that represent that 20-year hiatus. And so this burgundy represents the accumulation of unproductive habitat during that hiatus period. You can see immediately after the 1988 fires, we had a rapid increase. decline as it transitioned into more productive stuff. Another rapid and sustained increase during that 1997-2007 or 1998-2007 drought period. But notice too that the unproductive habitat has persisted at relatively high levels. Here again, relative to this mysterious period of time, 2009-2014, when bears are spreading rapidly. So maybe fires had something to do with it? A lagged response? Well, let's look at a specific case in point, going back to the Blackfoot Challenge. As anybody knows who lives in the Swan Valley or the Blackfoot River drainage, there was a lot of acreage that burned during 2017. Well, let's see what the consequences were, the implications were for conflicts. Here again is the good news story. Lots of conflicts, mitigation applied, dropped to low levels. Forever? Actually, 2018, we saw conflicts that were nearly at levels that occurred during 2003, which was the peak. Now, I was in the Blackfoot drainage talking to different people involved with the challenge, looking at the mountain face that had been scorched the year before. I said, do you think there's any connection between all these bears ending up on agricultural lands in conflicts and those fires? And they said, of course. So one datum, but suggestive of maybe a transient negative effect of fires, but nonetheless potentially a negative effect. One other factor that I'm a bit more confident in has to do with meat. Now remember that bears on the east front subsist almost entirely on meat, so it probably matters what was happening to the meat resource. Numbers of cattle, numbers of deer. This brown squiggly line shows stocking along the east front, numbers of cattle, the cattle inventory. Going back to 1985, you can see cattle inventories are at relatively high levels, and then they dropped, so there's a squiggle, but then recovered as ranchers restocked the range in the wake of a drought to record high levels. And there's no doubt that this destocking along the east front had to do with this epic drought that we all experienced between roughly 1998 and 2007. What was happening to deer in the meanwhile? That gray squiggly line towards the bottom is estimated numbers of mule deer along the east front. A corresponding decline in deer harvest, meaning many fewer gut piles available for bears to scavenge. So, here's that period of rapid range expansion out onto the Great Plains, 2009, 2014. A lot more cattle, fewer deer, diet switching probably, bears eating more meat from cattle. And remember that geospatial configuration where bears are funneled into these riparian areas and sent straight out into the Great Plains, which would have accelerated their expansion out onto the plains, facilitated by potentially a diet switch. And of course, then we see a skyrocketing incidence of depredation, in this case attributable to both wolves and grizzlies. So, wildfires, probably. Switches in, or changes in meat resources, very likely. So you all know who this is. And the reason I'm showing him is I never cease to be confounded by the fact that ecologists and biologists working for the government in this part of the world don't even bother to ask about what's going on with habitat and with diet as significant features of this system that might explain, in turn, demography and distribution of grizzly bears. There seems to be a profound lack of curiosity. And this is in defiance of the legacy of Chuck Jonkel. If he had a mantra, it was habitat, habitat, habitat. So what about the future? Almost certainly different from the present. If for no other reason because of climate warming. Here we're showing average annual temperatures modeled for the crown of the continent, going from the 1980s to 2080s. Red means warmer temperatures. It's going to get a lot hotter. And even if we have some slight increases in the amount of precipitation, those are going to be offset by the increasing temperatures to create ever more sustained and severe droughts. Think about all the changes I've documented linked to drought, the berry famine, destocking of native cattle, declines in mule deer populations, increases in wildfires. This kind of stuff matters. It's going to affect berry abundance in this ecosystem, almost certainly. Here what you see projected for 50 years from now, thanks to some work a graduate student of mine did for buffalo berry. In green, every place she modeled buffalo berry persisting. Everywhere, orange, everywhere she modeled we would lose buffalo berry. Obviously a model, so it's only one view, but we don't have any other projections. So you look at where the yellow is, it would suggest we're going to lose buffalo berry altogether from the Cabinet Yaak, most of the Selkirk, the core of the NCDE. When we look at chokecherry, even more catastrophic. Chokecherry persisting off on the Great Plains, being lost pretty much everywhere else in grizzly bear habitat. Look at serviceberry, another instance of catastrophic loss. Serviceberry moving up in elevation and persisting at only at higher elevations. With huckleberry, a little more optimistic scenario, projection, losing it pretty much altogether, probably from Greater Yellowstone, hanging in there in this part of the world, although in the net there will be probably losses. But when you look across all of these berry species, we're going to have the onset of a berry famine that won't end. What about army cutworm moths? Again, remembering that link to alpine tundra and nectar from alpine flowers. Every projection I've seen suggests that we're going to lose 90% of our alpine environments by the end of the century. What about numbers of people? Each one of those red dots represents a human residence. As of 2005, here's a projection for 7 years hence, a lot more of us, as we already know. So it's going to become even more of a formidable barrier off to the west side of this ecosystem. So with those changes afoot, those foreseeable changes, it begs the question, how many bears do we need in how many places to ensure a future for grizzly bears in this part of the world indefinitely? There's a lot of different ways you can answer that question or approach the question. For one, you can look at the magnitude of our so-called recovery relative to the magnitude of our losses. And what I've done here in turquoise, just chart losses of bears in the western contiguous US going back to 1800, having lost 97% of the bears we once had. This is what some people would suggest is recovery. Just looking at rote numbers of bears. So say we have roughly 900 bears in this ecosystem. There's great emphasis placed on the probable fact that that's 30% more than what we once had. My reading of all the current literature on minimum viable populations would in fact suggest we need near 9,000 grizzly bears. So the 900 bears in NCDE in light of that would be only 10% of what we need. Now when I offer a figure like that, a number like that, most people roll their eyes. As in to say, well, how could we ever have that many bears as a contiguous population in the United States? Probably not in the United States, but if we think of them as being contiguous with bears up into Canada, almost certainly. Which gets to this concluding bit, what I call a metavision. A more generous and robust vision of recovery for grizzly bears in this part of the world. Now to get at that, we need to step back and scale up. What you're seeing here is core distribution of grizzly bears in dark pink, peripheral distribution of grizzly bears in light pink, spanning the Canada-US border. Here are current recovery areas. Everything you see here in green is what's been modeled as potentially suitable for grizzly bears in the Northern Rockies. That is a lot of habitat yet unoccupied by grizzly bears. And when I say suitable, I mean sufficiently productive, sufficiently remote from people to support resident bears. And of course, most of it resides in central Idaho. Could we get bears there? Here are all the dispersal corridors that have been modeled, identified by various researchers for this part of the world. Appropriately enough, colored as if they were arteries, which in fact they are figuratively. But arteries only work as well as the heart to which they're connected. Hence, heart of the Grizzly Bear Nation. So if you want to have vigorous arteries, you need to have a vigorous heart. And we can contribute to that by endeavors such as the Blackfoot Challenge, what's been done in the High Divide, thanks to people like Steve Prim. We could have that. That is not unrealistic. And rather than talking at this point in time about removing Endangered Species Act protections and instituting trophy hunts to limit numbers of bears, to limit distributions of bears, we should be talking instead about replicating what's been done in the Blackfoot and the High Divide. More restoration, recovery, coexistence. And we can do it. It just requires investing resources. The only way we're going to do it, though, is going to be if we tell ourselves different stories. It has a lot to do with what goes on between our ears. If we continue to tell ourselves stories of death, domination, violence, intolerance, fear, we will never get there. But if we continue to increasingly tell ourselves instead stories of tolerance, compassion, accommodation, relatedness, we can achieve that vision. So I'll leave you with that thought. So I think we have what? I mean, it's awful goddamn hot in here. Pardon my French. Maybe we want to open the door. I mean, I would open it up to discussion, conversation, questions, however you want to configure it. I don't think it should be limited just to questions.
Well, I do have a question. All this uncertainty that you put around population estimates, both current and future, and all the factors that you just talked about that lead to this uncertainty. And then you have, on the other hand, the government's starting with demographics and focusing only on that, and their boundaries of error, which seem to be very small. Theoretically speaking, how do you get a federal judge to listen to your story of uncertainty?
Well, I think what's important to keep in mind is that this narrative is not entirely focused on litigation nor judges. What I'm hoping to offer is an alternative view that is comprehensive and coherent of what might be going in this on in this population for, the engaged public. I'm no expert on what would convince a judge in light of the law. We've got a really amazing concentration of lawyers in this room. So if they were, interested in taking that on, I would invite them.
I have no comment on that, but I have a question for you. On the Bitterroot ecosystem, you had it originally listed as a salmon berry diet. Salmon now gone. What are your thoughts about the adequacy of food sources in that ecosystem today as compared to when it was historically occupied by grizzly bears?
All of the modeling that went into producing those maps of suitable habitat did not include salmon as a factor. It was just looking at current configurations of habitat. So there was some work I did with Troy Merrill. Some of you may know Troy. There was work that Carlos Carroll did. There was work that Mark Boyce did. And it was all independent of the salmon factor. So I think if you were to ask the three of us, we would say absolutely there's potential for bears independent of whether there's salmon still there.
What's your most optimistic estimate or notion about the numbers of bears that could be supported in a recovered landscape in the lower 48?
In a recovered landscape, I would say probably about 3,000. I mean, I think that indeed we are at carrying capacity, hush my mouth, in Greater Yellowstone and the Northern Continental Divide, at least within the core, which I think is why you see this expression of bears out. They're very reactive to that diminishment. But the point is that carrying capacity has probably gone down. So that means if we want to have the same number of bears, they need to be occupying a larger area. But my estimate of 3,000 sort of, in a ballpark sort of sense, accounts for all that as well.
And then what are the prospects if we need to get to 8,000 or 9,000? What are the prospects of linking that with a healthy Canadian population that would bring us up to those numbers?
I think the prospects are good. There's been the Canadians have gotten serious about fragmentation caused by roads, if nothing else, like Highway 3 in Canada, just to the north of the border, is a major significant barrier to bears crossing. They're looking seriously at installing a wildlife crossing infrastructure on Highway 3. Done a lot of modeling to try to figure out where to put those crossing structures. So, I may be a fool, especially in light of my life experience, to continue to be an optimist, but I am an optimist. I think bears can live in a lot of places as long as we let them. Yeah.
I guess, how do you apply this narrative or counter the state of Montana's narrative, I guess, outside of this room and to people who don't necessarily have the same level of scientific understanding or scientific literacy? Just making it, how are you changing the narrative beyond this room?
Well, I think that's a topic of discussion, actually. I'm no expert on that. I guess what I can say, I would hope none of you were sitting there with your eyes glazed over at what I presented. My experience has been, and again, I may be deceiving myself, that I can present stuff that's actually fairly technical as long as it's visually compelling. And the public has a surprising capacity to engage with that. Not everything in toto, but enough to where they come away saying to themselves, wow, there's a different explanation for what's going on, and it's a lot more complicated, and actually there's a lot of uncertainty when it comes to numbers. I mean, if they just go away without those basic messages, that's an accomplishment from my perspective. Because again, this is about creating a context within which inevitably, for example, litigation occurs. I mean, I'm a devout believer in the importance of having a context so that people are not utterly mystified when they read in the newspaper that, yet again, the environmental lawyer succeeded. Forestalled something in court that people are going, oh yeah, there's some really big problems, aren't there? So that doesn't really answer your question precisely, but like I said, I think more to the point, my response is I think that's a topic for conversation. Yeah, Keith. Oh, sorry.
Blind side over there. I want to follow up on the carrying capacity because the message I get from this is that bears are going to be hungrier in the future. They're going to need more space to feed themselves. I mean, I think is that a fair way to boil it down to a very perhaps simple message to people? Because I look at carrying capacity issues from my background, which was many years ago in range ecology. And that's the message I'm getting, especially with the climate change.
Absolutely. I mean, if nothing else, you can go that little bit in what I presented about cattle stocking. You know, you got a drought, you got deterioration of range conditions, carrying capacity drops. You know, there's unambiguous data to show that. Likewise for bears, they're animals, they need food. Densities are responsive to, reactive to the environment. So if you want to have the same number of bears, lower carrying capacity, they got to be occupying a much larger area, probably much larger area.
David, are the huckleberries one of the keys from a persistence perspective for bears being able to make a living, so to speak, in central and north central Idaho? Is that
Yes.
like the key part of the most important part of their diet?
Yes.
Now and in the future?
Mm-hmm. Yeah, I mean, as I was showing, it very, very much tracks sort of those ancestral conditions that in large measure persist. That we have a berry economy to the west, minus salmon at this point. Yeah,
We're working on that.
Yeah, from 27,000 years by now of subjecting myself to NCD subcommittee meetings, I can tell you that the people who sit around the table, the managers who sit around the table, all their clue meters are on zero about any of the ecology about bears. They just listen to Fish, Life, and Parks and other folks and go, boy, we're out of the woods. And it's don't worry, be happy. You got 1,050 bears, rock and roll. What's the possibility of you putting this on at one of the upcoming NCD subcommittee meetings, offering to put it on?
well, I think the odds of it actually being presented are close to zero, but I don't know.
You know, I mean, if we start lobbying now and saying, what's the harm in hearing the latest and best from Cecily Costello, who does terrible presentations, and an alternative point of view from a longtime experienced, bear researcher, to give the subcommittee two sides of the coin, and then you guys decide. I mean, I think it would be an eye-opener. I think it would be a real eye-opener. They don't get any of this. They don't get any of it. They all understand that global warming is a big problem, which amazes me in itself. But they don't get that connection to, okay, the habitat's got a pretty good chance of tanking here. It's like, as Louisa says, the future is not going to look like the past. And they don't get that. Wow, look at this trend. Sky's the limit.
That's what they're paid to do.
Yeah.
Sorry, but
That's a good idea.
anyway, yeah. Rick, yeah.
The fires at the Blackfoot, where the mortality and conflicts skyrocketed the year after the fires. If I heard you right, you said maybe it had something to do with it, maybe it didn't, but if it did, what would be the connection? What could be some possible?
Well, I did not hear any alternative explanations from any of the people in the Blackfoot Challenge. But what they did comment on was you scorch that landscape. I mean, it was literally in the backyard of the agricultural lands in the foothills. There's no food there. And all the riparian areas just lead right out into the valley bottom, which is, there's lots of food there. There's irrigated pastures, if nothing else. So they were speculating, the bears moved, that were more inclined to hang out up there, moved out on the front. There were a few adolescents that were making a lot, causing a lot of problems, but that wasn't the totality of the story either. I mean, they gave full credence to the idea that the fires had affected, and also the mushroom pickers that were hard on the heels of the fires, sort of a displacement factor going on there. Yeah, George.
This is maybe a little tangential to what we're doing here, but when you talk about the vision for grizzly bear recovery, I noticed there wasn't a corridor an area going out toward the C.M. Russell refuge, and a lot of the work that's going on out there with the American Prairie Reserve, et cetera. And I was actually surprised to see a comment from their conservation person talking about grizzly bears the other day, which I thought was pretty bold for that outfit. But isn't there some real potential there as well to be starting to talk about with getting grizzlies back out on the plains in that area?
I grew up in western South Dakota. I grew up dreaming about bison and grizzly bears coming back. So I'm not a good one to ask because it may be more just, my fantastical imaginings. But I think there's potential. I mean, the point I try to make as often as I can is there is no shortage of grizzly bear food in the world. It's just that we humans happen to lay claim to much of it. So there's that. But related, what we do have is a shortage of tolerance. And, the tools, we have the tools. I hate to sound, again, like a TV show host, but we have the tools in the toolbox. Actually, I'm more like a politician. We do have the tools in the toolbox. Steve, I would invite Steve to talk about that, actually, Steve Prim. So it's not like we're operating in ignorance of what we can do, and that's why I really like to feature the Blackfoot Challenge, because that is one shining example where we have data to back up a claim that we've been successful. A lot of times there's been a lot of preventative work trying to get out ahead of the bears, which is a good thing, but unfortunately you don't have a crisis that you show you can have resolved if you're being that proactive. So, there's other models, other examples perhaps, but that's a good one. And I was contacted by a guy who's working for the American Prairie Reserve and said, send me all of what you got that I can present that would suggest we can have grizzly bears out there. So I did. And it wasn't like I didn't have anything. So, yes. Yeah. Although, I risk getting inflamed here. But a big part of the problem is that there are sort of bounds to the permissible questions in terms of what researchers can even ask, what they do ask. It has to do with what they're funded to do. So nobody has ever paid somebody money to model dispersal routes out onto the Great Plains and potential suitable habitat. Anyway, I'm losing track of, Claudia.
It's funny because based on the question, I was thinking of the same question as George asked. One of the things that has happened this past year, and it's been ongoing, is that there was another symposium, I guess it was in June, called Bison Unite Us. Oh. Was anybody here at the Bison Unite Us? It was like the 2-day thing. The law school started in the evening, I don't know, in June sometime, end of May. And then the Confederated Sailors Committee, they formed it. People came from all over. And it's so funny that these two groups don't talk. We were there and with the Sierra Club. We had a couple of articles. We had one early on, exploring wild bison restoration on Montana's northern plains, and this was before the Bison Unite Us thing, because people reached out from Bison, Jim Bailey. I don't know, you know Jim Bailey, right? Mm-hmm. Anyway, so there are people looking at it, and we're just late. The Sierra Club just kind of just on the periphery, just starting to look at this. But there's a whole other group of people who are looking at bison restoration across the northern plains. And if that's serious habitat, which it is, and less occupied, and the tribe of people.
Yeah. Well, I precisely. which is why I've gotten really intrigued about the bison-grizzly bear connection and put together that talk that I gave at the Roxy here in August, is trying to build that bridge between two charismatic animals. The bison being the more disadvantaged of the two, but nonetheless being better welcomed in certain landscapes. So if you can connect them, yeah, I think there's a lot of potential in that, absolutely. But I think, Dan,
Oh, I just was thinking off the top of my head on Tom Miner, more or less, is like a budding Blackfoot challenge. I mean, it just sort of appeared on its own. Luckily, you know, the Yellowstone's right there. But the tolerance level is off the charts. I mean, it's like people, those bears, pretty much, they're residents, they live there. They don't need to go anyplace else hardly, but now that they do, they're not getting very far. And we're getting, you know, the old broken record, we're not getting any help from Fish and Wildlife. We're getting none, absolutely nothing, which is startling. So they have to see this. They must see this. They know you've done this. So what?
well, maybe a derivative point as well is that, I mean, putting this presentation together, I really came to appreciate the power of a concrete example of where a difference has been made in terms of installing a coexistence infrastructure in a key piece, in a key landscape. And I think there's power in doing that for more places, like the Big Hole, like the Mattson Valley. I mean, there are other places where good stuff is happening that's promoting coexistence. And so I think there needs to be a connection made between all of these pieces so that people aren't saying, rolling their eyes. I mean, part of the narrative is, oh, well, people won't tolerate any more bears. You know, people, like all of us, all of them, everybody everywhere on Earth. But there's a lot of difference amongst different, you know, different people. So I think there needs to also be this message of hope, but connected to this picture of an ecosystem, a critique, bison. For me, the challenge is bringing all these pieces together and kind of weaving them into a fabric. Well, I don't know about that, but you have to ask. I would like to think so. Yeah.
You talked about the Blackfoot Challenge at one point. You suggested colonization, which implied to me that there's a reduced or depressed population there at some point, leading to this effort which helps bring it back. Did I miss something about this colonization?
No, bear sightings started to increase pretty dramatically about 1997, I think it was. But remember, too, that map I was showing where grizzly bear mortality was concentrated in the Bob Marshall Wilderness and adjacent areas from basically going back forever up through 1991. So I'm convinced that the Bob Marshall and Scapegoat were not completely depopulated, but the population of bears was considerably depressed. They were coming back. Maybe we had habitat changes afoot. I mean, I would argue again, 1998, 1997 was when we saw this burgeoning of wildfires, which could have contributed to pushing bears out. So, you know, all these dynamics afoot playing out. Yeah, Brett.
I want to share with everyone in the room that personally, I think one of the best things that we could do for bears today and for the future is to get behind the Northern Rockies Ecosystem Protection Act, because it's about habitat, habitat, habitat. NAREPA is a vehicle to protect Grizzly Bear Nation. And I just want to throw that seed out there again about people. Sometimes we forget about NAREPA, and I understand why we do. But I'm an honest believer in NAREPA, Because when David talks about heart and arteries, that's what NAREEP is about. It's about expanding the protection of the core habitat and providing biological connecting corridors so things like bears can come home. I think we need to do a better job getting behind NAREEP with all our free time. So, okay? So,
Just had a little anecdotal thing from Fish, Wildlife and Parks. Back in, probably 1997 or so, I was talking to Tim Manley, who's one of their Grizzly conflict people. And he said he had just flown the Apgar Range on the south end of Glacier on one of the bear transects. And he said there was about a 5 square mile area up there, and he counted 42 grizzly bears. And that area burned in a crown fire in 2001 and again in 2007. And last year, when Tabitha Graves with USGS was asked, oh, on your berry transects up there, are we seeing a rebound from those fires? And she said, nope, not yet. And those areas were dense with berries and dense with bears. And a couple of crown fires, and they have not bounced back. So
Yeah.
it's gone from 42 grizzlies in 5 square miles to, oops. And that's just on that little area, which is fairly small.
And just a comment on how climate change likely plays out. It's not like you have a gradual fizzling. It's that you have a increased amount of stress in the system by virtue of accumulating drought, whatever it is, and you get a disturbance like a fire, and the system flips. Because there's been all these built up, I don't know what the word metaphor would be, tensions that are released in something catastrophic. So that's maybe what we will see, is that we'll have productive berry fields, a fire, and the berries don't come back. I don't know, but that's more likely than not.
Well, we just raked the forest, you know.
Or the berries.
Yeah.
Yeah, Keith.
I'd just like to kind of make a comment about having seen an earlier version of this. And at our annual meeting earlier in November of Swampy Coalition, we had maybe 20 people in a room. And I just did my best to paraphrase just the portion here that you talked about, that population didn't necessarily drive these bears out. And these things we're talking about, fire, seeking out protein, berry crop failures. And I just want to give a positive message. The light bulb went on for everybody in the room. It's not a difficult thing to grasp. They had never heard any alternative to what we're hearing from the government agencies, both state and federal. We got so many bears, that's what's driving them out on the range, you know. And, you know, that people grasped it in a hurry, but they've never heard it from anyone before to start thinking in that direction. So I just want to be positive about the potential that this has outside of this room with lay people of being able to grasp this. It's a good message. Appreciate it.
Yeah, George.
And I want to reiterate that and what Brian said about the interagency Grizzly Bear Committee meetings. Because if you go there, you know, they spend most of their time listening to Fish, Wildlife and Parks regional guys talk about all the conflicts they've had with bears and all the work they're doing with chicken coops and all this other sort of stuff. And the whole narrative is about, you know, there's just more bears getting into more trouble all the time for them. And I think, you know, the idea of trying to get this presentation or something like it in front of that group, not so much for them because they're there to delist. You know, they want restrictions off and some of them want hunting season, and that's what's driving them. But to get the media there, get all the reporters around Montana, for example, that cover this stuff, and get them there and get them to hear a different narrative than the one that they're getting constantly from Fish, Wildlife and Parks and from the Forest Service and Fish and Wildlife Service. I think it's really important. I think it's something we should really push to do. You know, whether it's for the Northern Continental Divide Subcommittee or it's the whole group, The next time they meet, after, next week or whenever it is they're meeting, we really ought to push for that. We really ought to get the media there and try to change the narrative about this whole grizzly bear discussion. And we all have to start talking about it in the context of that broader vision of reestablishing 10,000 grizzly bears in Idaho and Wyoming and Alberta and British Columbia, because that's what we have to do to get the public brought around on this stuff, and that's really, really important. And try to put an end to this drive to delist and start hunting. That's all that drives those guys. You sit there in those meetings and it's absolutely maddening. And everything you read in the newspaper, whenever they talk about bears, there's this subtext of hunting, of delisting and hunting. That's just what, that's all they see. They have these incredible blinders on. And we have to change that. And I think this would be great, not so much for them, but for the public, the media.
Well, not to expand the boundaries of the discussion too much, but I would argue that in addition, we should be looking at suitable habitat elsewhere, further south. I mean, one of the bits of modeling that Troy and I did was trying to identify suitable habitat in Arizona, New Mexico. And using, I think, defensible models, and we came up with substantial chunks of habitat in that part of the world that could support hundreds of grizzly bears. And I would love to live to see, unlikely, grizzly bears on Escadilla.
So from Deirdre Bainbridge online, Liz Cheney has posted on Facebook that closing portions of Blacktail Butte and GTMP to hunters when grizzly bear are known to be on site across from the airport and subdivisions in Jackson indicates there are too many bears which need to be hunted, when in fact it means the bears are delaying hibernation for inappropriate food sources, hunter gut piles, due to reduced elk populations in appropriate places for bear. I am concerned that this talk does not address the drastic decline in the elk populations throughout the GYE, with man and increased hunting and elk reduction in the wrong places a factor. Why is the decline in elk population not addressed here as it was in past talks? The bear mortality increase due to elk hunters is a factor in the elk reduction. Just logical observations in living among elk and bear.
Well, I'd love to have another hour to talk about the greater Yellowstone. This talk necessarily was bounded looking at the NCDE, Northern Continental Divide. I agree, the elk what's happening with elk populations in greater Yellowstone matters substantially. I actually looked at trends in elk populations for around the NCDE. Nothing particularly remarkable. I mean, the elk numbers are hanging in on the east side. The other thing is, you look at the greater Yellowstone, there's roughly 67,000 elk. You look at this part of the world, there's 4,300 elk. So, orders of magnitude difference in numbers of elk as a factor in these systems. But there's a potload of deer up here. And there's demonstrable links between, two deer, bears scavenging gut piles left by deer hunters. So that's why the focus was on deer and cattle here, not so much elk, in contrast to when I'm focused on the GYE. I mean, the problem is, how do you bring all of this together? I mean, it's sort of like you reach the limits. I really pushed you here. I went on for over an hour talking about just this system. So.
Thanks, everybody.